God on this program, but many people have been convinced by science that the Word isn't dependable. Now, if you want to approach the subject of the age of the earth from Scripture, we dealt with that in a lesson that you can find on the archives, both at Facebook and at YouTube Live channel. And we'd encourage you to go back there and look at those archived lessons. We have hundreds of them. Hopefully they'll be beneficial to you. But there are a great many people who believe the earth is old. If you approach it from a scriptural standpoint, I think you can see that it is not allowed by Scripture. Many people, though, are convinced that science has proved that the earth is old. They'll refer to radiometric dating. We referred to that in our first lesson and pointed out at least three significant problems, assumptions that are involved that are usually not referenced when they say the rock is this old. But you have to assume there's a closed system in order to get an accurate date, and we know closed systems virtually do not exist in nature. You have to know the beginning conditions. If you use the analogy of the hourglass, you have to know how much sand was at the bottom when it started. And you have to know that the rate was constant. While that's a difficult issue, and we haven't got all of the problems ironed out, we do see strong indications that the rate has not been constant. And so without those three assumptions, you can't tell accurate time. A very significant factor of late involves radiocarbon dating of things that are supposed to be old. We've dated hundreds of dinosaur bones. All of them come out thousands of years, not millions of years. And coal and diamonds, supposed to be billions, certainly should have no carbon-14, yet they certainly do, indicating that the answer to the question of age is thousands, not billions, and has become the creationist friend. Moved from that in the second lesson to the geologic phenomenon. This is where I like to go anyway. Being trained as a geologist, I enjoy talking about the rocks. And when we look at the rocks themselves and we see jellyfish that are fossilized, that are just virtually nothing but hung around after they died long enough to become a rock, and you ask how long did it take that rock to form? You know it couldn't be long. When you see the fish in the process of eating its supper, the plesiosaur that is in the process of giving birth, these things clearly indicate, as Dunbar and Rogers say, good evidence that individual beds formed rapidly. Good evidence for that. When we see three-dimensional schools of fishes fossilized in place, and imagining that sinking to the bottom and maintaining its relationship to each other, it's just nuts to try to think that took thousands of years. When we see the trilobites playing Follow the Leader and frozen in the rock, we see indications this happened quickly. We look at the dinosaur bone and we see cell division, a process that takes 20 minutes, that's not completed, that's frozen in the rock. So how long did it take the rock to form? It couldn't take more than 20 minutes. It got caught in the concrete. And perhaps the most dramatic that we talked about last time involves now finding DNA in dinosaur bones. We know DNA is very ephemeral. It decays rapidly. And even the most optimistic physicist would tell you that it can't last more than a million years. It can't last a million years. Hundreds of thousands at most if you have a temperature near absolute zero. But here are supposedly 65 million year old dinosaur bones that have DNA intact. Now, that just tells you there's something very, very wrong with the picture we're being told. It tells us that the fossils are not old. When we can see the blood vessels, when we can see the tissue that stretches and then snaps back, the DNA, the cell division, those fossils are not old if you go with the scientific evidence. Now, let's think about that a minute in terms of these pictures that usually indicate great age. if the fossils in those layers are not old, what would that tell you about the layers? Wouldn't that necessarily say those layers are not old? So where is the time, the great ages that they're talking about? Well, we press that point, and people try to come up with a response, some of the professors, and today's answer usually is, well, it is between the layers, acknowledging that the layers themselves, when we look at the evidence, the very good evidence that they formed rapidly, indicates rapid formation. Then where do you get the time? Well, the time is in between. Where there is no evidence, I would point out, which is not totally true because there is some evidence in between, and it's negative to the idea of great ages. We'll see that. Derek Ager, who was past president of the British Geological Association, said, "We cannot escape the conclusion that sedimentation was at times very rapid." And looking at the jellyfish and looking at the polystrate fossils, the fossils that go upward through many layers, the cell division in the bones, and now the DNA, yes, there's great evidence that, and you can't escape it, that it was very rapid. Indeed, he affirms there are other times there were long breaks in the sedimentation. And what's the evidence for that? Well, he just asserts that where you have a break, that's where it was, where you don't see it, though it looks different. It looks uniform and continuous, but there had to be breaks, and that's where they shoehorn the time. It does look continuous, as we'll see, and we'll talk more about that in a moment. Notice, as he continues, the geologic record is continually lying to us. Now, good scientists go with the evidence wherever it leads. If it doesn't lead where they want it, they say, no, it's pointing in the wrong direction. It's lying to us, he says. It pretends to tell us the whole truth when it's only telling us a very small part of it. They've got to shoehorn great ages in between where there's no evidence. It may seem paradoxical, but to me, the gaps probably cover most of Earth history. It's the rocks that are supposed to tell the history. No, it's what's not there where most of the history is. It was during the breaks that most of the events probably occurred. It's the gaps that really matter. I don't think that's good science. I think it's the rocks that matter, the evidence that we can see, and they have to shoehorn what's not there in between the layers. For example, here near the bottom of Grand Canyon, you see the Coconino Sandstone lying right on top of the Hermit Shale. Well, it's not supposed to be that way, and in other places it isn't, and here there's supposed to be 110 million years in between. And so that's what they shoehorn in. And you look at that surface, it's like a knife edge. It doesn't look like anything in between. It's the gaps that really matter, you see. It does look uniform and continuous. When you expose the surface of a rock for any period of time, you're going to see erosion. Time produces erosion. But imagining millions of years between the layers doesn't fit here because you don't see indications of erosion. You see straight and smooth contact lines for 300 miles, the length of the canyon. And when you look at the contact lines, it becomes even more difficult to shoehorn that great period of time. You see ephemeral markings like the bird tracks, raindrop prints, and ripple marks that they last just for moments and then are moved along and disappear. We see this example near Glen Rose where the dinosaur footprints are found and the ripple marks are surrounding them. Now, how do you preserve ripple marks in the sand, which just move from minute to minute? Well, that has to be formed rapidly in order to preserve such detail. And then once it is preserved and does harden to become rock, what's going to keep it from eroding away quickly? the next layer has to come on top of it. So the base layer has to be rapid. The next layer on top of it has to be rapid. And when we look at scenes like this and understand that all of those bedding planes have ripple marks, then that just says all of it is rapid, one after another, after another, after another, if you understand the implications of the ripple marks and the other markings. There are other indications as well. One of the most dramatic is here at the intersection of the Red Wall and the Muov, Mississippian. Supposed to be at least 150 million years apart, but here's one on top of the other. But when you look at the interface, the Muov down at the bottom, 150 million years younger than the Red Wall. But then you go to the Muov and then back to the Red Wall. And then up to the Muov and then back to the Red Wall, back and forth 4 times. How do you skip 150 million years 4 times? Go back and get more. And what that says is they were laid down contemporaneously. In school, when the layers are interbedded, that says they're contemporaneous. That necessarily follows. And if that's the case, then they are not 150 million years apart. It looks uniform and continuous, and it is. And what we're taught in the textbooks is just not so. And if you look at the evidence, you can see that. So, how did we get so many layers forming so rapidly? Well, it happens catastrophically, and we have seen that happen on numerous occasions, especially with floods. One of the more dramatic examples would be with Mount St. Helens, which we observed in 1980, and then a few eruptions since then. But here in May, there was a huge explosion. A tremendous pyroclastic cloud went screaming across the countryside at about 150 miles an hour and deposited tremendous amounts of sediment, damming up Spirit Lake, which then broke through the dam, eroded through the newly laid sediment, leaving this canyon, showing the layers that had been laid down at 150 miles an hour in one afternoon. That formed rapidly. How long does it take layers to form? Well, we saw this form, and when you don't see it form, it must be slow, but when you see it, here it is at 150 miles an hour. That's not an example of slow, and some of it is very finely laminated. Some of it looks just exactly like the canyon layers that we see in the canyons that we're told are millions of years old. But this formed one afternoon, or at least over a 3-month period, most of it one afternoon at 150 miles an hour, leaving eventually a canyon that looks like this within months. Now, that looks like many of the canyons that you see at Grand Canyon. I'm sorry, that is Grand Canyon. This is Mount St. Helens. The scale is a little different, but the geomorphology is the same side sloping canyons and exactly the shape, and the layers can be seen very obviously. Reminds me of the cartoon that a friend of mine drew. This million-year-old canyon was formed by Mount St. Helens in 1980. And that passes for science. This is not science. We go to the caves where we see the beautiful speleotherms, the stalactites, stalagmites, and we're told this takes millions of years or hundreds of thousands of years. I was taught that 1 cubic inch took at least 100,000 years. That's in the process of changing, and they don't all say that, but you'll see that in the signs in the caves. How long does it take these things to form? Well, we got a real good example of that at George Rogers Clark Memorial near Vincennes, Indiana, right on the banks of the Wabash River. This is a clay bank, and the limestone came from the cave we just looked at, or at least within just a short distance. This is the Bedford limestone, and the water percolates down through the cracks in this memorial just like it does in the caves, and in the basement of that memorial you see formations that look like this. Now, it was locked and they would not allow us in, and I was denied entrance and had to get an order from the legislature to allow me in to see that. They're 5 columns, 11 feet tall, and after we blew the cover, after we published this and they could see, yeah, these did form rapidly, then it was covered in the newspaper here in the Evansville Courier-Press, 2009. Stalactites have been growing in the basement of the George Rogers Clark Memorial in Vincennes, Indiana because of leaks since it opened in 1933. Now, I took the previous picture in 1975. That's 42 years after it opened, and there were 5 columns and all kinds of stalactites hanging from the ceiling. So millions of years, hundreds of thousands, not really. Another dramatic example of this would be from Carlsbad Caverns, where they're really huge formations, and you've got lots of bats flying around. Some of them are not very fast. This one was slow enough to get caught by a stalactite. That's a pretty slow bat. How long did the stalactite take to cover the bat? Well, he probably died and laid there and was covered before he decayed. But here's the trapped bat in the stalactite in Carlsbad Caverns. But a lot of things that we're told are millions of years old. When you look carefully, you see obvious indications that's not the case. This boot, for example, was found out in West Texas, near Iraan, Texas. The boot is not petrified, but inside we have petrified bones. This is, by the way, from the M.L. Leddy Boot Company that was formed in 1922. This is a stitch pattern that was identified by one of the workers as probably from 1950. On the inside, we have a petrified cowboy leg. You see even part of the flesh around the bones preserved. Obviously, some kind of terrible tragedy took place, and most of the foot and part of the leg is rammed down into that boot, and even some of the pus, the festered part of that wound, is preserved as rock. We took that to the hospital to have them do a CAT scan, and they didn't have a name, of course, to go with it. They called it the Unfortunate Cowboy. We prefer to call him the Limestone Cowboy. But that was from about 1952, and he's petrified. There are lots of indications then, when we look at the rocks, of rapid and continuous formation of the strata. We see the detailed polystrate, that is through many strata or layers, like the fern that was 12 feet tall up above Knoxville, Tennessee. We see the shrimp and the jellyfish, the soft tissue, the DNA. These fossils say rapid, they do not say slow. And then we see that they are sequential, one rapidly right after the other, indicated by the ripple marks, having to be formed rapidly and then preserved by the next layer forming rapidly. Mount St. Helens demonstrates just how that works, one after the other at 150 miles an hour, over 600 feet of laminated strata in one afternoon. And then we see coal and oil petrification taking place rapidly. The coal seam of that fern was a part of that picture that shows that was formed rapidly. The oil takes about 20 minutes in the laboratory, and we've had several rather dramatic examples of commercial application of that just recently. I like to talk about the layers. I like to talk about the rocks. Now, why do you think the Earth's old? Not because of the layers and the fossils. You look at the layers and the fossils, it's just rapid everywhere you look, and just demands that when you see things like the dinosaur DNA. We see that the radiometric dating was not that dependable. It varies dramatically, and radiocarbon is really now on our side. So, now, why do you think it's old? I think it looks flooded. I don't think it looks old at all as a geologist. And when we saw the same kind of phenomenon, the horizontal laminated layers up on Mars, they said, this looks like a flood. Well, there's no water up there now. But on Earth, when you see the same thing, 70% of their surface covered by water, averaging 3 miles deep, that's a lot of water. But no, it couldn't be a flood here. When you look at the same kind of indications, I think there's some very obvious prejudice there. I think it looks flooded. Now, what we've focused on in these 3 lessons involves the evidence that is used by the evolutionists to say the Earth is very, very old, which of course is necessary for evolution. If it's not, then it's dead in the water. There's not time for it. So they are committed, they are determined to make it look old, and they just affirm that all the time. But when you look at the evidence that they use, the radiometric dating, the geologic phenomenon, it does not say what they're saying. The radiometric dating is not necessarily dependable, can be useful for a few thousand years. It gets beyond that, I think we're off the wall. Why do I think it's young? Well, we began the first session with Dr. Humphreys, Sandia National Laboratory, nuclear physicist, a PhD, and he had 12 reasons, and it'd be interesting to go back and see some of that material, which is online. But let's just look at some evidence from a fellow who is not a creationist. William D. Stanfield is one of the most vicious anti-creationists in the country, professor of biological science at California Polytechnic State University. And in his book, Science of Evolution, he's opposing creation, but acknowledges that there is good young Earth evidence. And here are his evidences: water from volcanoes, lava from volcanoes, pressure. Many familiar with the tremendous pressures that had to be dealt with down in the Gulf of Mexico when they drilled into a pocket and couldn't get the thing closed. How long do those pressures last? Just a few thousands of years, but boy, it's sure there. Wish we had time to look at all of these, but I'm going to focus on one just very quickly, and that's the last one in this list, the population dynamics. When you look at the population growth rate in the U.S., it is down considerably from where it was just in the last few years. 2017, it was listed at 0.81, less than 1% growth rate. Well, let's take that very slow growth rate. For 4,500 years, the time since the flood, 8 people, growth rate of 0.46. Now that's less than the present growth rate, which is very slow. So this is about as slow as you can get without ending it. So 4.6% times 4,500 years, that gets you to about 7 billion people, which is pretty close to where we are. Now we've obviously played with the figures there at 0.46, less than the present growth rate, but certainly fits the picture. On the other hand, let's try it with the evolutionist viewpoint and be very conservative, looking at just 200,000. That's a drop in the bucket for most evolution. But using the same growth rate, 2 people, 200,000 years, you got 4.312 times 10 to the 398th. That's an absurd number. To understand how absurd the 10 to the 398th is, just compare it with the electrons in the galaxy. That's only 10 to the 65th. Well, galaxy, let's expand to the universe from the galaxy. That'd really bump it up, wouldn't it, from 10 to the 65th to 10 to the 80th? Yeah. So 10 to the 398th is just ridiculous. While it's right on from the creationist perspective, it is absurd from the evolutionist perspective. I think population dynamics really speak loudly regarding the age of the earth. But all of these, according to the evolutionists themselves, provide evidence for the young earth. Uranium accumulation in the ocean can be measured very precisely. Water from volcanoes, most of the gas that comes out is H2O. If you take Paracatu as an average volcano, you could fill the ocean 7 times with one volcano. We've got over 600 active right